There's a countdown clock quietly running inside your house right now, and chances are you've never once noticed it. If you're raising a Chihuahua, that little dog might stick around for 16 years, sometimes 20. But if the dog you love happens to be a Great Dane, 8 years is already lucky. An Irish wolfhound, tall and majestic, often doesn't make it past 7. Same species, same basic biology, sometimes even siblings from the same litter, and yet one lives nearly 3 times longer than the other. Across almost the entire animal kingdom, there's a rule biology almost never breaks. Bigger animals live longer. Elephants outlive mice. Whales outlive seals. Giant tortoises can outlive several generations of the same human family. This pattern holds across thousands of species on every continent on Earth, except for one, the one sleeping at your feet right now. And here's what should stop you cold. The reason has almost nothing to do with the dogs themselves. It has to do with you, with your own body, quietly carrying the exact same secret, whether or not you've ever owned a dog. Stay with me to the end, because the final twist will change the way you look at your dog forever. It starts with a hormone called IGF-1, insulin-like growth factor. It's the reason a Great Dane puppy can balloon from 3 pounds to over 150 in under 2 years, one of the fastest growth rates of any land mammal. But here's the catch. The same hormone that lets them grow fast and huge is also quietly cutting their lives short. Think of it like a single dial with only one setting. Turn it up, and cells divide faster, bones lengthen quicker, muscle piles on sooner. But cells that divide faster also accumulate more copying errors over time, and tissue growing under that much pressure wears out sooner. There's no version of this dial where you get the growth without eventually paying for it. That bill is written directly into veterinary records. One large study on canine bone cancer found dogs over 40 kilograms were more than 45 times more likely to develop osteosarcoma than dogs under 10 kilograms, with Great Danes alone showing odds more than 10 times higher than average mixed-breed dogs. That same growth signal that built their massive frame shows up years later as tumors inside the very bones it grew so fast. This isn't just a dog phenomenon. Mice bred to lack a working growth hormone receptor live up to 40% longer than ordinary mice, translated to a human lifespan, the difference between dying at 80 and living well past 100. Smaller, slower growing, and dramatically longer lived from a single genetic tweak, confirmed study after study for decades. But the strangest discovery of all came from a small mountain region in southern Ecuador. There, a rare condition called Laron syndrome causes a mutation in the human version of that same growth hormone receptor. People born with it rarely grow taller than about 4 feet. For decades, doctors filed it away as an unusual form of dwarfism until one endocrinologist started paying closer attention to something far more interesting. Not what these patients were getting sick with, but what they weren't. Over 22 years of tracking 99 people with Laron syndrome, researchers recorded 0 cases of diabetes and only a single non-fatal case of cancer. Their own relatives, living in the same villages, eating the same food, but without the mutation, had a cancer rate of 17% and a diabetes rate of 5%. One genetic switch, turned off, and 2 of humanity's biggest killers nearly vanished from an entire community. Fewer than 300 people with this exact mutation are known to exist on Earth, and roughly a third of them live in that same cluster of Ecuadorian villages. This is still an active area of research, and no one is suggesting you'd want this mutation, since it comes with its own serious complications. But it's the clearest human evidence yet that the same dial controlling a Great Dane's growth is sitting inside you too, right now, quietly shaping how your own body ages. And that's not where this story ends, because here's the twist you genuinely didn't see coming. You'd probably assume humans built the small dog version of this story, that somewhere in the last 200 years breeders started selecting for tiny lapdogs, and accidentally stumbled onto a gene that slows growth down. That's exactly what you'd expect. It's also completely wrong. Geneticists went looking for when the small-size version of this gene first appeared, expecting to find it right around the point humans started domesticating wolves, somewhere between 14 and 30,000 years ago. Instead, they found it in the DNA of a Siberian wolf that lived 54,000 years ago, tens of thousands of years before a single wolf ever sat by a human campfire. The mutation wasn't created. It was already there, dormant, sitting inside wild wolf populations, doing nothing, waiting. Picture your own ancestors, tens of thousands of years ago, watching wolves circle the edge of camp at dusk, drawn in by warmth, scraps, and the smell of meat cooking over the fire. They weren't thinking about genetics. They were making a much simpler calculation, night after night. Which of these animals felt safe enough to let come closer? The smaller ones. The calmer ones. Without knowing it, every choice like that reached directly into a genetic switch that had been sitting untouched in wolf DNA for tens of thousands of years and quietly turned it on all across the ancient world at once. One researcher on the study put it perfectly. It's as if nature had kept this mutation tucked in her back pocket for tens of thousands of years, just waiting for the moment humans would need it. Nobody built the small dog gene. Ancient humans just found the one animal already carrying it and decided it was the one worth keeping around the fire. Now here's where the story loops back around, and it's the part that should genuinely make you angry, especially if you happen to love a big dog. That ancient mutation didn't disappear once humans found it. For most of human history, it just sat there quietly, keeping domestic dogs on the smaller side. Then, in roughly the last 200 years, something changed. Victorian-era breeders, chasing size for shows, status, and spectacle, started deliberately selecting for enormous, show-stopping dogs, towering guardian breeds, giant working lines, dogs bred to look as imposing as possible. Formal breed standards written during this exact period explicitly rewarded height and mass, and judges at early dog shows handed out ribbons for the very thing earlier generations had quietly bred out. Without meaning to, breeders were reversing tens of thousands of years of natural downward pressure, cranking that same IGF-1 dial back up, purely for looks. You could say humans spent 50,000 years slowly dialing a hormone down around a campfire, then spent 200 years deliberately dialing it back up in a show ring without ever connecting the two decisions. A giant dog today isn't simply fated by biology to age fast. In a real sense, it's paying right now for a purely cosmetic decision our species made a couple of centuries ago, one neither the dog nor its ancestors ever had any say in. And here's the twist that actually reaches past every dog you've ever seen and into your own body. IGF-1 isn't unique to dogs or to a small village in Ecuador. You have it too, running in your bloodstream right now, doing the exact same basic job in you. Driving growth, telling your cells when to divide, when to repair, when to keep pushing forward. Researchers studying human centenarians have repeatedly found something striking. Many carry genetic variants linked to naturally lower IGF-1 activity. It's still an active area of research, not a settled rule, and no single gene decides how long you get. But that same pattern keeps showing up in mouse labs, in Ecuadorian villages, and in the oldest people on Earth, the exact same pattern sitting inside every overgrown Great Dane and every ancient wolf. You're not just hearing a dog's story here. You're looking at a smaller, faster version of your own. So no, a Chihuahua isn't some biological accident science can't explain. It carries a 54,000-year-old genetic decision ancient humans never knew they were making, dormant in a wolf who never once slept near a fire. And a Great Dane isn't cursed either. It's simply paying, in advance, for the very trait that makes people stop and stare at it in the park. Same gene, same trade-off. Just very different bills, coming due at very different speeds, whether you're a dog, a village in the Andes, or a mouse in a lab. Next time you see a dog, any dog, big or small, whether it's yours or someone else's, remember, you're not just looking at a pet. You're looking at 54,000 years of choices, made by wolves that never met a single one of us, and by ancestors who thought they were simply deciding who got to sit closest to the fire. And somewhere in your own DNA right now, that same trade-off is quietly playing out, whether you've ever owned a dog or not. Every overgrown show dog, every Ecuadorian villager who's never had cancer, every lab mouse living 40% longer than its litter mates, all of them are running the same basic trade-off your own cells are running right now, just at a different volume. None of them ever knew what they were choosing, from ancient humans reaching for a calmer wolf pup, to Victorian breeders reaching for a bigger, more impressive dog, to villagers in Ecuador who simply grew up short, with no idea their bodies were being quietly protected. So here's the real question, and it's not really about the dog anymore. Would you rather grow fast and burn bright, or grow slow and last long? There's no universally correct answer, Only a trade-off every living thing on this planet is quietly making, including you, right now. Tell me in the comments.